Thank you.
Cool, so we are going to start, so we'll allow these lovely people to introduce themselves, and then I will open with the questions. So John.
Okay, hi everybody. I'm John. I have had over 20 years of doing cybersecurity, crypto, and so on, in everything from big cloud systems to tiny subsystems on microchips. But lately I've been most interested in things like smart cities. So I spent the last 3 or 4 years dabbling maybe in things like airports, self-driving vehicles, and things like that. And then in 1st of January this year I founded a company specifically dedicated to helping with the challenges of the exploding complexity of automation, smart cities, energy delivery, things like that. Cool.
Hi, I'm Holly.
Wait, that's for the video.
Oh, do you need both?
Oh, I need both of them. Oh, excellent.
Double mic.
I'll hold it in this hand.
Yeah, right. So I'm Holly. I am a software engineer on the Cortana for Windows, so at Microsoft. I started my career working on Paint 3D, so a little bit different. So I was working on democratizing 3D creation for the masses.
Wow.
And then I went to work on Xbox, and so I was developing features that would be on off-console experiences, so things that were on PC as well as on VR, so I got a bit of a taste in that. And now I work on Cortana for Windows, and so I'm working more in the virtual assistant space, kind of trying to figure out some of these unanswered questions about how people are going to be interacting with virtual assistants, what kind of value can they get from them, and how you can kind of balance between using like text, speech, things like that, and sort of finding the best way to deliver people the information that they want in kind of the method that they want to be delivered in.
Hi, my name is Marta. I've been in technology since the day that I started studying, not before that, which was 11 years ago. So yeah, I come from a very humanities background, and then as I started my studies, I decided to go into computer science and did my PhD in security and privacy, but actually never really worked in that field, mostly focused on blockchain. So I've been currently with Hyperledger currently for 3 years now. Hyperledger is an open source project under the Linux Foundation, focusing on enterprise blockchain solutions, and I'm a director of ecosystem there, kind of looking at use cases, looking at our community building, but also helping people understand the value of blockchain in enterprise setting.
Hi, I'm Shahram Mossayebi. I spent most of my time at academia, did physics, then cryptography, then back to quantum cryptography. Then eventually I got out of academia, did a bit of consulting in cybersecurity, got bored, decided to do a startup in 2016, which was Quantique. And crypto stands for cryptography, so just made it clear here. The idea was to, and still is, to combine quantum technologies with modern cryptography in an integratable, economical way to solve some burning cybersecurity issues, especially around IoT or connected devices, as we call it. We are over 3 years old now. We got products to basically provide multiple unforgeable device identities and cryptographic keys per device, and a key management service on the cloud side for enterprise to be able to manage the devices through their device lifecycle. Obviously, aiming for connected devices, smart cities is one of the biggest market, an interesting application that we come across it. And yeah, happy to be here.
Cool.
We're also hiring in case you guys are interested.
Talk to him afterwards as well. Cool. All right, then. So let's start with the first question. We'll mix it up, but we'll go ladies first. So Marta, your favorite 2 innovations? They could be like a reality now, or they could be like a pipe dream that might not even exist yet. Please share.
Well, I have a private answer to that question, but come and ask me afterwards. Not sure if I want to get that on video. But in general, mobile devices, I think that this is something that specifically smartphones, that really changed the way that we interact, the way that we communicate, but also just the way, if you think about it, when I was younger and I met a boy during summer, I had like 5-minute flirt with him, and then I went home and I never saw him again. These days, I happen to have a 17-year-old girl at home, and she is in long distance relationship and actually never lived in the same city as her boyfriend for the last 3 years. So this really changes the way that we interact, and it is really important to me. The second one is 3D printed drugs, because that's something that just blows my mind. The fact that we can design a drug so that it gets released in the right moment, and it's a combination of 5 drugs, and we just make sure that they don't interfere with each other and so on. That I just don't understand how that's possible.
I didn't even know they existed. Holly, what's yours?
I'm obviously incredibly biased, and so I'm super interested to see where the future of virtual assistants is going to take. We are right at the beginning of this process, and a lot of people too tend to think that the virtual assistant space has already been kind of taken over by your big dogs like your Amazons and your Googles. But if you start actually kind of looking at really the quality of the responses that you're getting back and what people are actually really asking these kind of virtual assistants, a lot of the time it ends up being like, hey Alexa, play Spotify. Like that's kind of the depth that we're reaching at this point. And so it's interesting to me to see what kind of real value that we can be doing, and actually, at least on a Microsoft side, what kind of like productivity that we can start adding to people by really cutting down the amount of steps that people have to go through, and really adding like proper natural language to these kinds of services. So you don't have to specify like very specific queries to get them to do what you want. You can really start to speak to them like you would an actual assistant, and actually like use the language that you would normally do, and not have to specify context of like, oh, okay, I've asked for like when is my meeting with this person, and now can I like several turns later be like, oh, okay, can you actually also send this email to this person? And they would just know, because it would just be built into the fabric of these virtual assistants. And so I'm quite curious to see actually how good we can really make these technologies, because I really do think that we're quite at the beginning of this process. It's only been the last couple of years that we started exploring this. My not so existing dream is, at least I'm a contact lens wearer, and so I'm quite curious to see if we could do like heads up display through contacts. I think that would be really cool to be able to have like a feed come up or directions given to me as I just look around. It gets a little bit creepy. Panel questions, yeah, a little search over here, yeah. So I'm quite curious to see if we can do some of those technologies. I've seen very early articles written about this stuff, but very early. So we'll see what ends up coming our way.
Okay. Shahram, you got a mic?
Yeah, sure. I think I'm more interested in intersection of these new technologies. I mean, we're living in an era that we have so many interesting things happening, like such as AI, AR, VR, biotechnology, 3D printing, quantum computing. And I think what I'm really interested to find out is what's going to happen in intersection of those technologies. What's going to happen when we combine our AI algorithms with the power of quantum computing to train our algorithms. What happens if we use quantum computing power to do an AR type applications? What's going to happen if we manage to solve some big problems in biochemistry to do some drugs, whether it's 3D or not, but more targeted type drugs with different type of effect. So for me, I think we are so advanced in so many areas, but what I'd like to see in maybe next 10, 20 years is what happens if any of those fields get kind of entangled and get combined.
Quantumly entangled.
Yeah, sure, why not?
Okay. John?
Right. So for me, I always get a bit sort of torn with these questions, because they say that sort of technology is just everything that was invented after you went to high school, and innovation is everything that hasn't happened yet. And yet if you look backwards in time, I mean, honestly, things like writing and formalization of the number 0 are probably the most impressive things that have ever happened. But as far as sort of contemporary innovation goes, there's a couple. So not within my field of expertise, but I think very important indeed was CRISPR. I think the idea that you can massively accelerate proper, well, scary or not, technology has no morals, right? But I think even outside of the sort of common, slightly scary sort of DNA bioengineering, genetic bias kind of stuff that people spread around, the possibilities for smart cities, for smart living, of engineering organisms that are actually able to eat the stuff that's otherwise bad for us and grow is just incredibly good, I think, and is going to yield a lot more good than bad. And the other one, to take a sort of more straight down the line technology approach, I think is RISC-V. And it took us a long time. For those of you who don't know what RISC-V is, today pretty much every computer you own has an Intel chip in it, and Intel chips are quite expensive. Every mobile device you have in it pretty much probably has an ARM chip in it, and ARM chips cost quite a lot to license. RISC-V is finally an attempt to make free open source hardware. That's not to say that you get actual chips for £0, but it's to say that you can take the design, send it off to a foundry, and they will essentially just charge you the price of the sand and the process to get your chips out without any of the licenses. I think in the context of the smart cities, this is super important, because if you're going to make things smart, that means basically everything has chips in it, and right now it is not possible or feasible to sign all the contracts you need to sign, to pay all the money and the licenses and the royalties that you need to pay in order to have all those bits of stack. And frankly, it's a waste of time for every single company, every Microsoft, Amazon, Google, every Bosch, Siemens, Honeywell, whoever, to all invent the same thing in a silo separately with their own patent pools. We need to share. As Lara said, this is a co-creation effort. There's absolutely no point in creating the same thing in the world more than once. And this actually takes the open source qualities of software that have made the internet possible and moves that into the hardware domain, which I think is going to be really, it'll be under the radar, nobody will ever talk about it at the breakfast table, but it is going to have a big impact.
I really love how you brought that up, because that's one of these paradigm shifts I was talking about a bit earlier. If you look up Jeremy Rifkin, he talks a lot about the sharing economy, and that's a lot about what IoT is going to enable. So if you actually want to sustain the planet and our cities, rather than like one power plant or whatever just creating all this energy, you've got to share it out amongst everything. But then the sharing economy applies to everything. It could be your house. Apparently, in America, I didn't know this, but you can actually rent your car out. So a bit like Airbnb, but apparently when you're in work all day, you can rent your car out.
It's brilliant.
Yeah. Have you done it?
Oh, many times.
Oh, wow.
I lived in States, so I used it a lot.
Yeah.
And the best part of it is that you can actually, thank you. The best part of it is that you can actually rent out a super old school Mustang or a very fancy Porsche and just go for a ride for 2 days to LA and feel like a movie star.
There we go. So this sharing everything and not reinventing the wheel. It's like this is when technology is just moving faster and faster and faster. So what do we want to talk about next? I think let's go with AI. So one of the things that scares me is being a mindless sheep just controlled by AI. You literally only get presented the reality based on your past choices or what your friends see. So question for the panelists, there's a big topic on AI algorithm ethics. And what it means is could you sue the algorithm? Is it a person? Is it an entity? Could you sue them for making a choice for you or maybe not presenting all the choices? So open to the panel, whoever wants it first. AI algorithm ethics. Any scary stories? Oh, here we go.
I think Cortana has to answer.
Cortana.
Hey, Cortana. So I've done a bit of reading around this space, and I'd say that if you're sort of new in this area, even not new, a couple good books to read is Hello World by Hannah Fry. That's quite a good kind of introductory into algorithms and AI and ethics sort of around that, and she covers a good couple spaces. And then the other one I've been reading recently is called Invisible Women. And so both of those, I've sort of been gathering kind of some of my information across those, as well as some different talks that have been given at Microsoft and my job as well. But I'd say I always find this is quite a challenging question, because it's difficult with these kinds of AI algorithms. A lot of this information or these algorithms are proprietary information. And so if you have a problem, how do you actually prove it's the algorithm? You don't know what goes into the algorithm, you don't know what decisions are being made, you don't know what information is being put into it, because it is a company's private knowledge, basically. It is their own thing. As well as then there's the question of like, okay, who do you actually sue if you do that? Do you sue the third party that is using this algorithm? Do you sue the person that made the algorithm, the company? Or do you sue the person that made the decision that, I mean, if you know what's gone wrong, then who actually made that decision? So there's quite a few questions around who do we sue, how do we sue, and how do we actually get to know what the problem is? I think some of my other questions around this is probably the reason why I guess you are suing is because you think the response of what you've gotten out is unfair. And a lot of that, at least in my mind, some of the things I've been reading about is they're unfair is because there's a lot of data bias that ends up that's feeding into these algorithms. And this data bias comes from a few places, which is like there's just not enough data or there are gaps in this data. And so they're being fed into these algorithms, and this historical data bias is being fed into what is making decisions in our present day and are kind of aggravating and potentially like accelerating these biases that are coming out. Like I think probably a few of us would have heard about, I think it was Amazon, I'm not sure, about one of these companies who was using this algorithm to kind of like vet CVs before they actually get in, and it was like
that's lots.
Yeah, there's loads of them, right? And so, but it's like, okay, well, you see, like, oh, good. White men are really good software engineers because they're the ones that have always been software engineers, and so unless you have that on your CV or whatever, then it ends up getting fed into the fact that like, oh, okay, someone like me or some of the other people here wouldn't be seen as a good candidate because previously they weren't the ones that were being hired in these roles. The other part ends up coming down to the people who are deciding which kind of information that is really useful in this algorithm. And so like Invisible Women talks a lot about how, in this case, particularly like women, it was the focus of how we have different opinions and perspectives and life situations that mean that we have different value that we can be adding into these situations, and so some information that could be really useful isn't being actually even given to the algorithm in the first place or isn't being emphasized. And so for me it's quite a few areas where it's not a simple question or is not a simple answer.
Yeah. A lot of these questions I'm going to ask, you could have a whole event.
You could have a whole event.
I really want to like get everyone's awareness up. Sounds. Anyone want to add anything on AI?
Just gone on a monologue.
But it was a very interesting monologue. From the other side of things, I think that why we are so excited, or people are excited about AI, also in my domain is smart contracts, is that this basically delegates the responsibility. All of a sudden there's this machine that is responsible and there's this algorithm that is doing everything. So not a single, like today if you sign a contract and your lawyer advises you to sign a contract and it goes bad, you just sue the lawyer. If your doctor screws up your whatever surgery, you sue the doctor. But if it was an algorithm that, or the robot that performed the surgery, and well, it's not a human being. You could put a robot into a jail, but I don't think this is really punishment to anybody. So I think that it beautifully kind of feeds into not willing, or a lack of willingness to take responsibility for our actions.
Oh, it may. I think if I may a little bit of spice. So I worked on this in my previous role. I worked in a defence company, aerospace company. In fact, looking at all sorts of technologies that can make all sorts of quite serious applications work better. And when you start to compare the reality of AI in real-world applications to the press image of AI, you quickly discover that the two are very, very far apart indeed. And actually pretty much everything that we have today that's called AI is just automation. And we already know exactly what to do when somebody writes bad software, is we sue the person who put the thing into service. And that's it. It's that simple. If you look at things with self-driving cars, for example, we know exactly where the responsibility lies in those kinds of places. And when you look at planes, we know where the responsibility lies. There was never any reason to change any of the regulations or the legal framework. Pilot is still ultimately responsible for deciding whether a plane is ready to fly, whether it's fully analog or fully digital. It doesn't matter. You see what's in there and you assess whether it's good enough. And it's that simple. So actually, as you sort of intimated, and I kind of sound like your 80-year-old uncle at a party, because I tell this joke at every place I go to, so I'm going to keep doing it. So don't get my favourite, it's also my only AI joke, but it's my favourite AI joke. Okay, an AI walks into a bar, says to the barman, I'll have what everybody else is having. But because that's basically what everything does today. The root of everything we have right now is either computer vision based, which is entirely about tagging and similarity assessment, or it's trend based, which is entirely about telling you what thing to buy next or what music track to listen to next, which is not ever going to get us close to AGI, which is what people are all worried about. So there are plenty of actually quite sensible, skilled people in places like Montreal working on explainable AI and serious actual AGI. The reason you don't hear about that is because it's very hard and they're taking a very long time over it. But yeah, honestly, I'm not worried about this stuff.
So I'm going to step in there. So basically, I'm going to segue into the next question. So AI has actually been around since the 50s, 60s, 70s, but it's just not financially viable or possible to really use it because we didn't have the computing power to do it. But I was joking with my uncles the other day. We had my cousins around, so my uncles were all in IT, and they were saying, that hard drives were like, 250 meg used to be like the size of a sofa. And we just had Amazon deliver a 2 terabyte literally the size of my thumbnail. Literally 24 hours later it arrived. But so with AI, what's going to be the big game changer with all of this IoT, big data that we have to analyze is quantum computing. So the next question, which we do have some quantum cryptography experts on the panel here, quantum versus cryptography.
Yeah, okay.
What do we need to know about this?
Yeah, I know about this stuff. I wouldn't really necessarily put it quantum versus cryptography.
Or so, AI, because now we can do AI, enables an AI in smart cities.
Sure. Quantum technologies, such as any other technologies like AI, is a new technology. Cryptography has been around for many years now. So pretty much we kind of know what it can do, what we can do with it, what are the limits, where we can innovate still. So kind of have a good sense of what's happening there. On quantum technologies, we're still not sure where the limits is. We understand some difficulties, for instance, to realizing a proper quantum computer, but we're not quite sure what exactly then it can do for us. So when, as a new technology, it have a good side, it could have a dangerous type of bad side. But I think it's kind of up to us how we use it. So usually when people talk about quantum computers, and then the moment they say cryptography, all they talk about is all the cryptographic stuff that we have today, all the security that we have today is broken. A couple of years, we are doomed, it's gloomy, and etc. That's not really the case. It's gonna take ages to have that quantum computer that will be able to do the same. In the same time, we could just change the type of cryptographic algorithm that we're using today, which are safe against those type of quantum computers coming around. But at the same time, quantum computers, because of their intrinsic randomness that they've got, they could add a lot of value into security and cryptography. And essentially, that's where we're playing. That's the game Quantique tries to play. So you can benefit a lot from quantum technologies right now as it grows. You need to be aware of the dangers that it could pose to the infrastructure that I'm to plan, and already a lot of plan been in place. And I think I'm not too worried about it, to be honest.
All right.
Can I have a quick question to the audience?
Get your questions for the audience.
How many of you actually understand quantum computing? Okay, so maybe
everyone with your hands up, you're lying. It's not true.
So maybe just like 5 seconds on quantum computing.
Okay. What is it?
The ultimate challenge.
Well, so the idea is in a classical world that we live in, we only could have one position or one bit that we can compute on. So at each, in a computing process, we could just go step by step, do some form of computation on one form of bit, get an output, then do something else on it. In a quantum world, you have and a state, which is known as a superposition state, which is a combination of all possible variation of a system. So in case of bits, for instance, we have 0 and 1. So a quantum state that represents a bit, or known as qubit, at the same time essentially is 0 and 1, and we don't know which one it is unless we actually measure it. So when you compute on a quantum state, it's like you're running a function at the same time on 2 bits, 0 and 1, and you just keep continuing that. So in a process, when you just keep doing that, instead of you get to have an exponential speed up compared to a classical version, because each time you basically double the type of computation that you're doing. But that's just a quantum state, so you still don't know what the answer is. At
I don't think anyone's any clearer.
Could I just ask a very brief question, just in
Sure.
your question, what you said? Would you say it's a little bit more similar to the way that human brains work, in a way where we can kind of hold a lot of information in our head?
It enhances the human brain in my world.
Not really, to be honest.
Well, maybe we'll discuss more about
Sure,
this.
of course.
I think
Yeah.
maybe a couple of questions from the audience, because you guys have obviously been listening to it.
If I can, correct me if I'm wrong, the way that I think of quantum computing is, most of you saw the Black Mirror Choose Your Own Adventure thing. So that's kind of how quantum computing works in my headspace, which is basically I start at some point and all of the decisions or the endings to that story are defined. I just don't know which one will be the one that I'll arrive to. Like if you were the god or the script writer, you would know which path leads to what. But me as a person who is watching Black Mirror, I have no clue. All of them are possible, depending on how I choose it.
Probably easier. It's a hard one. Who has a question? Oh, who has their hand up? Come on, someone must have a question. Oh, wait, we need a mic. We need a mic.
Say your name first.
My name is Yasmin. So I'm trying to follow the quantum computing stuff. What's an application of quantum?
Well, I mean, obviously, that gives you an exponential computing power. So the question is, in mathematical situation, we have this complexity theory that explains mathematical problems have different level of difficulties in order to be solved. And we know theoretically that some of those mathematical problems cannot be solved in considerable amount of time with current computing power that we have, classical ones. But when we consider, again, theoretically, this exponential speed up that quantum computers might be able to give us in real life, then some of those problems can be solved. So it essentially could give you an edge that you can solve some hard problems that thought to be impossible to solve with classical computers, but when quantum computers are around, we are able to solve them.
Can I have a thing?
Yeah, of course.
So using that property, I think it's actually really unhelpful. Usually, that every time anybody asks what quantum computing is, they start by saying what a classical computer is, and then say what quantum computing isn't. They're completely different, and trying to explain things in terms of superposing zeros and ones, it almost gets there, but as soon as you start to understand, you realise that the analogy breaks down, it doesn't make any sense anymore. It's analog, it's wavy, it's approximate, forget that. But the nice thing about that is that chemistry is fundamentally wavy and analog and approximate, and so right now there's a challenge to all science. Because the idea is that science basically starts off with a hypothesis, and then you test that hypothesis, and then you see if the results match your hypothesis. And so when you're trying to do really complicated things, like work out exactly how to use your CRISPR in order to build a protein, in order to have some kind of outcome, like a really super successful drug, or something that can eat all the plastic in the ocean, what we do right now with classical computers is the equivalent of sort of building a model of that protein in Lego. And we take bloody ages to build this intricate model of this one variation of the infinite space of protein and chemistry that might happen. And then if it doesn't work, you have to take the whole thing apart again and build it again. So one of the applications of quantum computing, which is just impossible today, no matter how much we speed things up and no matter how many AI emergent organic algorithms we have, is modelling of biological and chemical systems for that kind of chemistry engineering, for the real world analog engineering that's just so hard today. That sort of thing is a quantum leap forward.
I have a question on this. So, Bitcoin, right, takes what?
Not quantum.
5 to 10 minutes to process the block. Will quantum destroy that? Make it.
That's you, honey.
The honey part was because I'm
Oh,
married.
I should say yes. I'm not a horrible man. I'm actually married to this lady.
He's allowed. Bitcoin, blockchain, quantum. That's a good question. So, sorry?
For VCs.
For VCs, that's a good question for VCs. I don't know if it will change anything or not. Sure, the algorithms will be broken slightly, and some of the cryptographic proofs that we are using for blockchain and specifically for Bitcoin with the proof of work, which basically means that I'm trying to solve a riddle, and the first person to solve a riddle is the person who gets to put the new block into the chain. So if we have something that is able to compute those things and solve the riddle much faster, obviously then the whole process of or the challenge becomes just not useful in any way. Currently we are relying on the fact that computing takes energy and takes time. So the more the more energy I spend, the less time it takes me to figure out the solution to this problem. So that way I get to put the next block into the blockchain, submit my transactions. With quantum computing, I will just be able to do it with an instance. But as you were saying, obviously it's not like one day we'll all wake up and there will be a quantum world and everything will be broken and the apocalypse day or whatever else movie you want to watch, all of a sudden all beasts will die because quantum computing arrived. That's not how it works. It's a slow process. And already right now we have a lot of amazing work being done on post-quantum crypto, as in cryptography, that can be then the basis of blockchain and Bitcoin and cryptocurrencies and anything else that relies on cryptography.
Cool. I'm gonna call time at the moment. I'd love to ask these panelists more questions, but we started a bit late, so we have to move on to the next panel. We'll all be at the pub, most of us.
Yeah. Susan, you can tell them all about where we're going to the pub to have all these amazing
Yes.
conversations.
On the first, a hand for our panelists, John, Holly, Marta, and Shahram. Another panelist, step up.